Right, let's have a look at hybrid functions, also known as piecewise functions by the Americans. Hybrid functions are called piecewise functions on the TI CAS handheld, so you'll see them referred to as piecewise functions. Here is a piecewise function for us on our CAS handheld. We've got f of x is equal to 2 when x is less than negative 1. It's equal to x squared plus 1 when x is between minus 1 including the minus 1 and up to but not including positive 1, and it's equal to minus x plus 3 where x is greater than or equal to 1. And this is what the thing looks like, okay, on the screen of the CAS handheld. It is a continuous function. What I mean by that is that the line is unbroken right throughout the three component parts of this piecewise function, okay? And the handheld treats the hybrid or piecewise function seamlessly with any calculator steps involving this, even though it is a hybrid of a number of separate functions. This is a great feature. Please make sure that there is no ambiguity as to the points on the boundary between adjacent hybrid sections. Each x value can only belong to one function. I'm referring to these boundary bits here. You'll see here that I've got f of x is 2, where x is less than or equal to 1, and then you'll see that here that f1 of x is equal to 2, where x is less than negative 1, and then the actual point negative 1 is included in the middle section here, okay? And you'll notice in the middle section that positive 1 isn't included, but it is included in the third section there. That's what I'm trying to say. Yeah? Great. Also, for discontinuous adjacent hybrid sections, please be especially careful to use open and closed dots properly where appropriate. Please also, for discontinuous adjacent hybrid sections, please be especially careful to use open and closed dots wisely where appropriate to specify coordinate points properly. Also, for discontinuous adjacent hybrid sections, be especially careful in the use of open and closed dots at the boundary points. You'll see what I mean in a moment on another screen, okay? This is what you get when you go for a piecewise function to enter one on your TI CAS handheld. You go into the catalogue or the book, and then you type in number 5 for tab 5, and there's a little template entry there, okay? And the next screen shows you how you enter the number of parts. That's the prompt that you'll get. In this case, we've entered 3, and then you go for OK. Then it'll put that on the screen where you enter each component piecewise function and its domain, okay? Very easy. Now, what I'm showing you here, ladies and gentlemen, is once you've entered your piecewise function, I've entered it as f1 of x in this case, you can then go about doing various wonderful little tricks on your CAS handheld like this. f1 of 1, it automatically knows which component part to go to without you telling it. It goes to this one, and it works out the answer is 2, which I think is pretty cool. And look at this. This is really marvellous. This is an integral, a definite integral from -1 to +3. So it has seamlessly worked out the integral across all three piecewise bits of this function, and it's come up with the answer seamlessly without any trouble at all. That's really cool. Have a look at this one. This is a discontinuous hybrid or piecewise function, and you can see because I have to take my pen off the page to trace that function from one path to the next, don't I? So it's discontinuous. Please be very careful to use open and closed dots at the points of discontinuity to make it clear which x and y coordinates are defined at the boundary points, which function they belong to is what I'm trying to say. So you'll notice here that f1 of x equals 2 for x is less than -1. So there's an open dot there because the point where x is -1 is not covered, is not included in this component part of the piecewise function. You see what I mean? Yeah. And for the second component part, you'll notice that the -1 is included, but the +1 isn't. Yeah? Yeah, you're getting it now, aren't you? Good. And the third part, we are including where x is +1. You see? Very, very nice.